Good morning, 802. So I wanted to be able to teach you all since you don't really remember. Well, I know you don't remember what's going on. So I kind of wanted to have a mini lesson so you all can be familiarized with the lesson. So this is coming from 11-2 in Nori Math, the assignment that you have due on Friday. It's talking about quadratic functions. So if we look at our key concepts over here, let me change this to blue. Remember in class when we talked about the parabola, if it opens up, then we have a minimum. So that's talking about if we have something like that, that's opening up. And down here would be our minimum versus if the graph opens down, we have a maximum. I'm not sure if the lesson talks about that, but if it does, I did go through the lesson. I didn't see minimum, maximum, but if it does, you'll be prepared. Also, please note that this is coming from Power Note 31. So if you were lucky enough to have Power Note 31 before we got out of school, then you're good. Okay, so when we're talking about quadratic functions, remember that a quadratic function has a standard form right here, standard form that is f of x equals a x squared plus bx plus c. Remember that a cannot be 0 because if a is 0, then the whole quadratic function is gone. It disappears. So we're looking at a, b, and c. They're constants where a does not equal 0 and the largest exponent is 2, and that's what we're talking about right here. So in order to be a quadratic function, the highest exponent must be 2. The first few questions ask you all to identify quadratic functions and in standard form, and this is what you'll need to look at here. This can be something you can read on your own. It's basically talking about that if A is bigger, then it's going to be a stretch. If A is smaller, which is 0 and between 0 and 1, then it's going to be a compression. Remember, we talked about reflections. That's when A is negative. They're going to ask you to graph a quadratic function. I think that this graph would really help you all when trying to graph the quadratic functions. Moving on, how do we find the axis and move this out the way? How do we find the axis of symmetry? So briefly before school ended, we talked about the axis of symmetry being negative b over 2 times a. And you all bear with me. I'm going to get a pen prayerfully this Saturday. So next week, you'll be able to see my penmanship a little better. So the finding the axis of symmetry, this is the formula you will use to find the axis of symmetry. B over 2 times a, and then the whole fraction is negative. And the b is coming from whatever b is in the standard form, and so is the a. Let's see. Remember, if they ask you to graph a quadratic function, you're going to create a table. We've done that plenty of times in the book. Create a table, and that'll help you come up with the coordinates for the parabola. Okay, so now I want to move down to find the vertex. So they ask you on one of your questions or two of your questions to find the vertex. And the first step is to use that axis of symmetry equation. You're going to do that. And then you're going to plug in the value of x into you're going to plug that value of x into the original equation that they gave you. So as you can see, my video is about to end in 20 seconds. If you need any more help, please contact me on Remind. I'm there. And I'll see you all in the next lesson. Bye.